Hi, my name is Marley, and today I'm going to be talking to you about covalent bonds. But before I do, I wanted to do a quick refresher on a related topic known as the octet rule. This rule states that atoms tend to want to have 8 electrons in their valence shell so that their electron configuration can be as stable as that of a noble gas such as this neon atoms. Or in rare atoms such as hydrogen, this rule is satisfied with only 2 valence electrons. But how do atoms that do not have 8 valence electrons satisfy this octet rule? They do this through bonding, and the type of bonding that we are going to be discussing today is covalent bonds. Covalent bonds are bonds that form between two nonmetal atoms involving the sharing of electrons. This sharing of electrons allows for both atoms to satisfy the octet rule and obtain 8 electrons in their valence shell. An easy way to understand covalent bonds is if you think of these bonds as a friendship. In order to form a friendship or a bond with your friends, you need to share a little bit about yourself so that your friend can know about your life and so you can know about theirs. When you do this, your friend and you are sharing information, and in turn, you form a bond. Similarly, an atom needs to share some electrons with another atom in order to form a bond which allows each atom to have a full valence shell. But sometimes, in a friendship, there is one friend who tends to do more of the sharing and takes up all the talking time. In this situation, one friend becomes the sharer and the other the listener, making the friendship stronger for one person than the other. This also can occur within a covalent bond. This happens when one atom in a covalent bond has a higher electronegativity than the other, meaning that the electrons gravitate more frequently to this atom. When this happens, the electrons spend more time circling that atom and less time circling the other atom in the bond, making one side more negative and the other more positive. This interaction is known as a polar covalent bond. An example of a polar covalent bond is a molecule that we cannot live without, H2O or water. In a water molecule, 2 hydrogen atoms and 1 oxygen atom share electrons with each other. However, the oxygen atom has a greater electronegativity than the hydrogen atoms, so the electrons spend more time near that end of the molecule. This means that the oxygen side of the atom has a partial negative charge, and the other end has a partial positive charge, making a dipole moment within the atom, or a separation of positive and negative charges. However, sometimes a friendship is made of 2 people who share stories equally and both have a strong bond with one another. Just as some covalent bonds are made of atoms which have similar electronegativities, making the electrons equally attracted to both atoms, leading to a non-polar covalent bond. Also, sometimes friends tend to form in groups so that people can have multiple close friends in which they share their life. In this event, many bonds are formed in order to make one large friendship. This also occurs in covalent bonds when some atoms need to share more than one electron in order to fill their valence shell. Take water again for example. Oxygen, in its singular state, has 6 valence electrons, so in order to fill its valence shell, it needs to form 2 bonds with hydrogen atoms. Or similarly, nitrogen has 5 valence electrons, and when it is bonded with another nitrogen atom, it must form a triple bond with 3 shared electrons in order to complete its octet. So in summary, a covalent bond is a bond in which atoms share electrons with one another to complete their octet and obtain 8 electrons in their outer shell. There are 2 types of covalent bonds: polar covalent, in which the electrons are unevenly shared among the atoms, or nonpolar covalent, in which the electrons are evenly shared. These bonds can exist between many atoms to form large molecules, or just between 2, but both involve sharing electrons between non-metal atoms. Thank you for watching my video today, and I hope I could help you understand covalent bonds even further.